Hello friends, uh, in this video we are going to solve production planning problem model 1 using Excel solver. This model we have discussed in class. In this our objective is to minimize total cost of production subject to flow balance constraints. Total availability is equal to total demand plus inventory, capacity constraints and non-negativity constraints. Now, in this spreadsheet model here, all the black color, right now, I have not entered anything. I have not started modeling. All that you see in this spreadsheet right now is input data. For example, this production cost, which is 20 rupees per unit. Uh, Similarly, overtime production cost is 25 rupees per unit. Inventory is 3 rupees per unit. And similarly, we have production capacity input data that we cannot produce more than 800 units per week using regular time production and 200 units using overtime production per week. So this is production capacity data. Demand for all the 4 weeks is given here, and we need to optimize, we need to find optimal production plan for this production planning problem. So here we are referring these orange cells as decision variables. What are these decision variables? These four cells here correspond to xj decision variables: x1, x2, x3, x4. These are the quantities produced using regular time production mode. Similarly, these next four cells are yj variables, which are overtime production quantity. And the last four variables here is the inventory at the end of jth week. Now, knowing these variables, it is very easy to calculate total availability, which is total availability, let's say, at the end of every week. So this is left hand side of the first four constraints. What is the left hand side total availability? It is simply the quantity x plus y. Okay, so quantity produced using regular mode of production and the overtime production mode. So that is our total availability in week number 1. Let's drag it. So we get the left hand side, uh, but this is not enough because we know in the first week we are assuming that inventory I0 is 0. So for first week it is fine, but for the second week we need to add inventory of from the first week. So in the second week we are going to add inventory of the first week. Okay, then I am dragging this formula. Okay, so let's check it for the fourth week. In the fourth week, total available quantity is total quantity produced using regular time, using overtime, plus inventory from the last week. So this is left hand side formula is okay. Let's see the right hand side for our constraints. On the right hand side, what we have is demand plus inventory. So for the first week, what we have is demand is mentioned there, plus demand inventory is for the first week is here. So this will be total right hand side, which is the total demand plus total inventory. So let's drag this formula. This is constant throughout, same throughout. So in the last week, we are assuming anyway, optimization is going to take care of it because of the minimization objective function. In the last week, I4, inventory 4 is going to be 0. Whether we keep it or we don't keep it, it doesn't matter much at this stage. Okay, so uh, yes. So yes, in the mathematical formulation, we don't see I4, but here we have added inventory 4. If we double click here we have added, but anyway, we know in the fourth week, inventory is going to be 0 because we are penalizing inventory. And we know in the fifth week, there is no demand. Therefore, I4 is going to be 0. Fine. So effectively what we have are the left hand side and right hand side of the first 4 constraints. Okay. Now we still need objective function. Okay. Now first of all, we can write, if we want, we can write the entire formula in this cell itself directly. But to make things easier, what are we doing? Let's see how much we are producing total using regular time in the 4 week, which is formula here, total using regular time. Similarly, this is total using overtime production. And the third total is total inventory in 4 weeks. So when we know these total quantities, then it is easy to calculate the total cost of regular time production, which is the total regular time production multiplied by per unit cost, which is 20 rupees. Okay. So effectively, what we have done here? Let's double click here. This is total production. So in the objective function, look at the first term only. It is sigma xj into 20, the cost of regular time production. This is why we are getting this first cell here represents the first term of objective function. Fine. Now we can drag this. So the second term here represents the second cell here is the second term in objective function, the total cost of overtime production. Similarly, the third term here is the total cost of inventory. Okay. Now, knowing the total cost here, all the 3 components, we can calculate total cost, which is summation of all these 3 costs. Fine. So what we have right now is we have written the objective function here, or the total cost, the formula for total cost. In order to minimize, let's go to solve this problem, right? Converting this mathematical model into spreadsheet model, solving it using Excel solver. Let's go to Excel solver. Now in Excel solver, what we have, we need objective function. Objective function, the total cost we have, first of all, we want to minimize. And objective function formula we have written in this cell H16. Our decision variables are in the orange cells. And now we can add constraints. The balancing constraints, mass balance constraints, total availability, total production, total availability must be equal to total supply must be equal to total demand. That's it. Okay, so that simple formula. Add. So the first 4 constraints we have done. The second set of constraints, which are the regular time production cannot exceed 800 units in every week. Okay, so we are writing for all 4 weeks regular time production is here. This must be less than equal to the capacity, which is 800 here. Okay, so let's add this. Now the overtime production capacity constraints, in all the 4 weeks, this overtime production cannot exceed the capacity, which is 200. Okay. So effectively what we have done here, look at this. Objective function we have mentioned, minimize decision variables we have mentioned, the capacity constraints are there, and this flow balance constraints are there. Yes, we want non-negativity constraints, so variables are non-negative. We are using simplex solver. and let's click solve. Okay, solver found a solution. All the constraints and optimality conditions are satisfied. So yes, we have obtained optimal solution, which in this case here is 79,600 is the cost. Let's check the data again. Once again, is this matching with this? Yes. 1,800. Yes, here we have 800 instead of 900. Okay, so there is 100 unit less as compared to this example. In the image here, instead of 900, we have we have 800. Fine. Okay, so this is our optimal solution that and this is our plan, production plan, that we are going to produce in every week. We are going to produce full at the full capacity of our regular time. Overtime we are going to use only in the first 3 weeks, not in the fourth week. We have some inventory only in the second week. Okay, and the corresponding cost of total production cost for this 4 week of planning horizon, we have the total cost is 79,600 rupees. So let's change the value to 900. Okay, save, go to solver again. So of course, when we have increased the demand in fourth week and we are going to optimize the problem again, of course the objective function value, which is the total cost, must increase. So let's go to solver. Only the data is changing, no change in the model. Solve. Okay, again found optimal. Okay, and we can see instead of 70, it has increased, the cost has increased. And now unlike the previous plan, we have 100 units of overtime production in the fourth week as well. Okay, so 100 increase in the demand, therefore 100 increase in the overtime production. Good. Now let's check check it with some more data. For example, let's increase the capacity at anywhere. Let's say here, instead of 1200, it becomes, let's say, 1500. Okay, let's see what happens. Of course, if it is feasible, then the cost should increase further. Let's increase it significantly, 1800. Save, solve. Yes, so solver could not find a feasible solution because the total demand is much more than the capacity available. Therefore, there does not exist any feasible solution, which this is why we see a warning sign here. Fine. Now let's reduce it for back to this and play with data more. Suppose if we reduce the cost of production, let's say make it 18. And solve it again. This is not very helpful. This is fine. Let's change the capacity instead. Yes, let's reduce the capacity, whether we have modeled the capacity constraints properly. Let's make it 600. Save it and then solve. Yes, again not feasible. So therefore it looks like our model is correct. We have correctly modeled the problem. We'll continue the discussion in our class.